Bonjour génie engineers, welcome to my problem a day series. In this video, we're going to calculate force members of a given truss using the method of section. These type of questions are important if you're taking FE Civil, Mechanical, other disciplines, or if you're just taking statics class. Now, if you're for the first time and you just want to learn about engineering or just how to engineer a better life, don't forget to subscribe and make sure you hit the bell so you don't miss out on future videos. Now, let's get started. Oh yeah, everybody now. Okay guys, so we're giving a truss and we need to calculate the force in these three members. Now we're going to use the method of section for this problem because we weren't asked to calculate all the members. Now in the previous video, I know I used a different method. You can call it kind of method of joints, but that's because we needed to calculate the force in all members. So I don't really recommend that method here, because it's going to take you a lot more time. So let's start solving this. So the first thing we're going to do, just like in the previous video, by the way, if you're interested in the previous videos, I'll make sure to leave the link somewhere above there in case you guys want to check it out. I used a really quick method for you to solve any given truss. So the first thing we're going to do is calculate the reactions. Summation of moment at A equals to 0. Let's pick this as our positive sign counterclockwise. First, let's determine our reaction forces. We have Fx and Fy. And then here we only have one component because it's a roller. So we take the summation of the moment at A. So what do we have? So I have minus 80 times this distance, because that's my moment arm, 15. And I have minus 80 because my moment is going this way and 80 is going the opposite direction of my moment. So it's going to be minus 80. Then I have minus 80 times 30, minus 80 times 45, and then minus 80 times 60, because this is my moment arm. It's from the force to where I'm taking the moment. That's your moment arm. Then I have minus 200 times 12, minus again because I have my moment this way and I have the force going the opposite direction of my moment, and the moment arm is where my force is acting to where I'm taking the moment. So that's this distance, which is 12, minus Fx times 12, and this is equals to 0. Again, same thing, it's minus because my moment going this way, Fx is going the opposite direction of my moment. So if you solve this, you're going to get Fx is equal to 1,200 kilonewtons, but it's going to be negative, and negative just means that the direction that we picked is wrong and that it should be the opposite. So it should be going not this way, it should be going this way. So this is 1,200. Let's do the summation of the forces on the y direction is equal to 0. I'm going to pick this to be positive. Then we have Fy minus 80 times 4, because we have 4 80s, so I'm just going to do that, is equal to 0. So Fy is equal to 320 kilonewtons, and this is positive, so that means the direction that we picked for Fy is correct and it's going to stay going upwards. Now let's do the summation of the forces on the x, which is the last equation we're going to use. Let's select this way to be positive. So we have Ax minus Fx, because minus Fx is going this way, plus 200 is going the other direction. Now if you solve for this, you get Ax is equal to 1,000 kilonewtons, and this is positive, which means the direction that we selected is correct. So let's write it in the diagram. So now that we solved our reaction, we can start solving for the force in the members. So let's identify them. So we have AB, which is this force member, and we're trying to look for GB and GH. So these are the forces that we need to calculate. So I think the best way is to do this. We're going to cut a section and then we're going to identify those forces. So the best way to do it is cut it this way. So we're going to cut it this way. So the way how you start understanding or getting how to cut, and I think that just comes from doing a lot of problems and just doing a lot of practice, and eventually you're just going to start seeing it. That's really the best way to do it. So let's take this and just draw it down so that we can kind of isolating it, and then from there we can just calculate it. So let's do that. So this is what we're pretty much working with. So what I would recommend is that we take the summation of the moment at B. And the reason that is because if we take the sum at B, we're going to cancel FGB because it's going through the point where we're taking the moment, so that doesn't count, and FAB doesn't count either. So those two members, they cancel out. So this is how you start seeing what's the best cut. Is you try to cut in a way where what is the best way so that I can take the moment and cancel as many forces as possible. So that way you have just one unknown, and that way you can just solve it. So if we take the moment at B, FGB cancels because it's going through it, and then FAB as well. So we're only left with FGH. So let's take the summation of the moment at B equals to 0, and let's pick this to be positive. So we're going to have minus FGH times 12, minus, because I'm taking the moment this way, right? It's the same thing as earlier, and my force is going the opposite direction of my moment. So I have minus FGH times 12, then I have plus 1200 times 12, and this is from this Fx, so that one is the same direction. So my moment is going this way, and I have a force going in the same direction, and this is my moment arm. And then we have 320, so I have, that one is going to be minus, because I have my moment going this way, and my force is going up, so it's opposite direction, so I have minus 320, and this time my moment arm is going to be this distance right here. That's your moment arm, which is 15. And this has to be equal to 0. Now, if you calculate this, you will get an answer of 800 kilonewtons. And this is going to be in tension. So the answer is positive, right? We got an positive answer. That means the way we showed FGH in this direction stays that way, because if we got a negative answer, that means it has to go the opposite direction. And the reason why it's in tension, it's because, like I mentioned in the previous video, when you look at the joint, and if the force is pulling away from the joint, that means you have tension. So that's why we have tension here. Now the next thing is, let's take the summation of the forces on the y equals to 0. Now we have FGB, which is going down, and then we have plus Fy, which is 320, equals to 0. So FGB is equal to 320. And again, this is positive, so that means the way how we select it is going to be positive. And it's also going to be in tension, not because it's positive, but because the force is pulling away from the joint. So that's why it's going to be also in tension. So I have summation of the forces of the x is equal to 0. Now I have FAB, and then this is the positive sign that we selected, and for here going up is our positive sign. So I have FAB, then I have plus 1000 the AX, plus, or actually minus FX, because it's going the opposite direction, plus 800 for the FGH. So don't forget the 800 right here. Now this is going to be equal to 0. Now note that we didn't really include these forces because these are on the other side. Usually when we cut, all we care about is from the cut to the other side. We don't really care about this portion. So if you plug in this, you will get an answer of 600 kilonewtons. And this is, it's positive. That means the direction that we picked is correct. But this time is going to be in compression, because FAB is going towards the joint, so it's creating compression. Okay guys, so let me know if you want to see more of these problems in the future, and I will make sure to address it. Now, don't forget to like, subscribe, and make sure you share with your friends who might find it helpful. Thank you guys for watching, and I will see you soon. À la prochaine. Oh yeah, everybody now.